Welcome to the Future of Coding. Today we have Glen Chiacchieri on the podcast. Glen has a resume that many listeners will be very familiar with. He has worked at the MIT Media Lab on Scratch and at Dynamicland with Bret Victor. He's known in these programming research circles for his legible mathematics essay, his Flowsheets programming prototypes, and the Laser Socks game, among many other projects. So welcome, Glen.
Thanks, Steve. It's good to be here.
Yeah, it's awesome to have you. So I like to start these conversations off by talking about your kind of origin story, how you got into programming and specifically this subfield of improving programming.
Yeah, I got very lucky. Feels important to acknowledge that first. So in college, I went to Northeastern University for a degree in what eventually became computer engineering, although I kind of made my own software engineering degree out of that. And in that program, there's a kind of co-op program where you go to work for a company for 6 months, then go back to classes, then go work for possibly another company, and then go back to classes. And there's usually 3 of those. I only did 2, and I did them at the same company, which was a startup with a kind of like, there's a freight logistics startup called Open Mile. And I actually learned to program on the job there, which was the lucky part. I was not qualified for that job, but I learned it all very quickly. And that was my first real foray into programming. And then over the years, I got more and more interested in kind of the act of programming itself. So how I was doing this thing that I was doing and getting more and more like, wait, how is this? What is actually going on here? Why am I making mistakes? Like, what is all this?
That makes sense. So what, who or what was like your first entry point into this way of thinking? Was it like Alan Kay or Seymour Papert or Bret Victor? Because I know, you're one of the people who's interested in all of those folks.
Yeah, it was totally Bret Victor. The first thing I saw from him was Magic Inc., his essay on design. While I was working at that startup, someone showed it to me and my mind was blown, as tends to happen when you read or watch things by Bret Victor. And then I got more into his work. And I think shortly after that, he came out with Inventing on Principle, which had a lot of the, I think, core tenets of what I saw or what I currently see as important in programming environments.
It's interesting. You're like an OG Bret Victor fan. You're pre-Inventing on Principle.
Oh, is that what OG is?
Well, I think like a lot like Chris Granger, and I was reading an article that said that John Resig, a lot of the people who were really inspired by Bret Victor, I think were inspired by Inventing on Principle. So you predate those guys.
I still think Magic Inc. is an amazing statement. And to me, it was important about how to communicate well. And I think that's kind of an underlying thing in Bret's body of work that maybe isn't totally appreciated, is that he is probably one of the better communicators using media that I've ever come across in my entire life. And so that essay for me is like captures the very important thing about how to communicate well and like, okay, examining, what a software experience is actually trying to provide for someone. And then saying, why not just do that, like kind of directly instead of this like interactive thing that at the time I think was more prevalent than it is today. There was a lot more kind of interactive like widgets and boxes and pop-ups and things like that. But today, I think some of this, his principles in that have come more into software, actually.
Yeah, I remember when I first looked at Magic Inc., and I one of the headers of that essay is like interaction considered harmful, something to that effect. Yeah. And I reacted very negatively to it. I felt like I almost wanted to stop reading the essay because it felt like almost anti-technology. Like, what do you mean? Like, of course interaction is a good thing. But then when you read it, you're like, oh, wow, like interaction means like dialogue boxes and like clicking, like a lot of clicking, and nobody likes lots of clicking. To your point that a lot of the principles that he talks about in that essay are have been incorporated into mainstream interfaces is that he redesigned Amazon's search interface. And it just is such an amazing example of the power of his principles. And I immediately after I saw that went, recently to search something on Amazon and see what it looks like today. And it looks so similar to the to like his redesigned version. So I don't know if they got it from him, but somehow his ideas have found their way into the mainstream.
Yeah, and I think part of that essay is quite well received, if I recall correctly. And so I assume it actually has sort of permeated out into the people who are designing these apps now. It's like it's over 10 years later at this point. But I think one thing that Bret does well in that essay is seeing underneath what the kind of core thing that a person wants to get out of using these different interfaces. So for Amazon, it wasn't like the person wasn't trying to click a link or something and see more information. They just kind of want to know, is this a good book or is this a good product? And I feel like Bret kind of took that as like, here's the actual thing they're trying to do. Let's design the perfect experience for that, or whatever perfect means.
Yeah, I'm totally with you. I remember whenever I read that essay or reread it, I like immediately after I find myself looking at all my interfaces, like the apps to find movies, the apps to like figure out which train to take. They're like all woefully inadequate. Like it's not helping me to do the thing I'm trying to do. And I want to redesign it in a Magic Inky kind of way.
And after I read that, I started actually doing what you just described. I started making like all these prototypes. I remember seeing later when I visited Bret and met him in person, I saw that he had designed a BART schedule, which was like very Bret Victory. It's like on a piece of paper, just like a static. I was like, oh yeah, I gotta design my own one of these. Like, what is the perfect Magic Ink style BART subway train schedule layout that I can quickly get the information that I need if I'm just running out the door or about to run out the door.
Yes. So what'd you come up with?
Oh, well, it's a little hard to describe through audio.
Got it. Does it look similar? Because I know in Magic Ink, or maybe it was a different essay, he has a BART scheduler thing.
Oh yeah. That was the software. He won the Apple Design Award for that, I believe.
So did yours look similar to that, or was it kind of a different take?
It was a different take. It was mostly just here's the schedule for the different days, and here's how a format that you could see at a glance, when the next train is coming. And it was just a thing to stick on the wall, not a widget to have on your computer screen. Got it. And it was useful. I got to use it every day.
Oh, cool.
When I lived in California.
Yeah. So I know that you're also a big fan of Alan Kay, to the point where you've started a wiki for collecting a lot of his work. So I'd be interested to hear kind of how you fell into Alan Kay's work and how he's similar and different from Bret and what you find interesting about him.
Oh yeah, there's a whole world in Alan's mind is one way of putting it. The way I got introduced to Alan's work was through Bret. So at one point I started working with Bret Victor directly in his lab, just working with him. And at that point, that lab was started by Alan Kay. That was kind of the thing before Dynamicland, which wasn't extremely public. It was called CDG, the Communications Design Group. And so in the process of working with Bret, he just recommended, and I found a bunch of different links to Alan's works. And I kind of went down the rabbit hole, so to speak. Whenever I find someone who has really interesting work, I kind of tend to consume it all and kind of download that person's published work into my mind and then start churning through it, which I think is a great way to learn. So at that point, I started reading all of his different works, which I really enjoyed because for a long time I saw my role as a professional not as a person redesigning programming, more a person helping people to understand things, and programming was one of those. And Alan had a lot to say both about programming, about how the human mind works, and he has a lot of really good ideas and work behind software artifacts supporting human understanding.
Yeah, I've heard Bret say that people always give Alan Kay credit for being this technologist who, invented like Smalltalk or object-oriented programming, but that like drastically undersells him. Bret says that he's like one of the greatest philosophers of our time. So, like, could you maybe like give us a kernel of Alan Kay, philosophical wisdom to whet our appetites?
Oh man, that is a tremendous challenge. I'll try and give something though. I would say Alan is not maybe the best philosopher, but one of the best systems thinkers of our time. He has a really deep sense of how important it is to be systemic thinkers. And these systems are like our political system, technology systems, education systems, systems in lots of different areas. And his vision, I would say, is something like a kind of really well-informed democracy. He views democracy, especially like the American democracy, as one of the like shining examples of something that was really hard to invent. And then once we had it, it's really important to hold on to and nourish and give rise to more of these beautiful kind of democratic ideals. And specifically, he would like that to happen through education, through people learning what he calls powerful ideas. These ideas that are, not obvious to someone just kind of growing up in a natural environment. Things like scientific thinking or democracy, or just kind of basic human rights. That's a really weird idea in the span of history. Like most people have not experienced human rights. And so he wants to nourish those through education and having really good educational experiences, especially for children.
Yeah, I think that's I think you did. I gave you a hard prompt to like give me some kernel of Alan wisdom, but I think that was a great summary, and it reminded me of something that Bret said to me when I spoke to him in January. I was talking about how great Scratch is for kids, and how, because it allows them to do things that they want to do anyways, like make games and make things dance and music. It allows them to do the things they want to do anyways, but learn to code at the same time. And Bret's response was that I don't remember it exactly, but it's something to do with he referenced the shit crayons essay that just because kids do creative things in Scratch or Minecraft doesn't mean that those things are good tools, and it doesn't mean like kids are learning some form of programming, but it doesn't. It's not that interesting because kids would make things move and play games anyways. They'd be doing those things anyways. Instead, we want to build tools and environments for kids to do things they wouldn't be doing anyways, such as like democracy or scientific thinking, the sorts of non-human universals. He said that Alan had this list of like the human universals, things that people do anyways, like singing and dancing, and then the non-human universals, the kind of enlightenment values that we cherish. Anyways, kind of a little rant, but I thought this could be a good transition point to talking about Scratch, which I don't think is shit crayons, but I get Bret's point there.
Yeah, I think it's a subtle, maybe not exactly subtle, but it's a non-obvious point that I'm glad that Bret has, although I also don't think Scratch is shit crayons. I want to acknowledge the amazing artifact that Scratch is and what kind of concrete human good has come out of it.
Agreed, 100%.
So yeah, I worked on Scratch as a contractor it was only about 7 months, but it was a very long 7 months in a good sense. Like I got really friendly with the creators of Scratch, and I still talk to some of them to this day, and I go back and visit occasionally. And I kind of just downloaded the ethos of the space and got a little bit more sense of the design values of Scratch. And I started learning a little bit about the history and the backstory of how Scratch came to be, which I think is very interesting. And from like it to me, it is one of the like top ideals or the kind of best examples we have so far of what a good programming environment can do, what a good programming environment is like. And I think there's a lot to learn from both how Scratch is designed and how Scratch was made in the first place.
Yeah, awesome. Let's get into that. Great. So yeah, tell us the story. How did it come to be?
So this is all through my understanding. So if I get any details wrong, I'm sorry. Sorry, Scratch team. But so I think it starts with Alan Kay, actually. So Alan had produced eToys in the 90s. And eToys was kind of a small talk specifically for children in some ways. It was this kind of all-encompassing software system that allowed you to do very powerful things within it and do this kind of simulations and other kind of programming tasks that Alan wants to help children be able to do. And one of the main programmers from that was John Maloney. And John came over to the Scratch team, to the lifelong kindergarten group at the Media Lab, I think in the early 2000s. And Mitch Resnick was also talking with Alan, and they had a bunch of different retreats. So there's a lot of cross-pollination between what was kind of Alan's group and was the not yet Scratch group. And it started with this kind of like, Mitch Resnick and I want to say Natalie Rusk. Natalie was this amazing designer who I think is a big part of why Scratch is so important, or why Scratch is so good, because she is one of the people who started the Computer Clubhouse, which is a bunch of after-school programs for teaching kids how to use, or having a creative environment for kids to use, like Photoshop and play music and try all these new digital tools that are coming out. And Mitch and Natalie saw this happening in their computer clubhouses, which are now kind of nationwide or even worldwide at this point. And we're like, kids aren't programming. Like, how can we get them to program? And that's when they started seeing eToys, and we're like, oh, I think there's something here with eToys. So they kind of brought John Maloney in and started making their own thing inspired by eToys. And it feels important to say Natalie sat down with children every week for 2 years and just like watched them use different iterations of Scratch until it was like kind of airtight. This, like, especially the first interaction with Scratch.
Fascinating. Yeah, I had heard parts of that story before, like the retreats that the labs kind of went on together. I think I spoke briefly with Mitch Resnick a few months ago, and he almost made it like a bit of a competition between Scratch and eToys. Like Alan was saying, I want to teach kids like scientific thinking, and eToys was a bit more serious. And Scratch kind of took a more playful, video game-ish approach. And then I don't really know what's going on with eToys, but it seems like Scratch has certainly won the adoption game.
Yeah, it's easy to set up that kind of. That's actually a quite common dichotomy, I would say, is that I've struggled with quite a bit, which is the kind of Scratch approach versus the eToys, and trying to understand how they're similar and how they're different, and kind of what values each works on. And, is it a good thing that Scratch is so popular? I think in a lot of cases for me, yes. But I also hear Bret's criticism, and I know this is Alan's criticism, that there's kind of a sense of wanting to do more, or that there's more potential to do that Scratch doesn't quite hit in some way.
Yeah. So I guess I want to ask kind of more explicitly, like, in what ways do you feel like Scratch points towards the future of programming? And then what are some of the places it leaves room for improvement?
Yeah. So I'll tell a brief story. One thing I've done is teach programming to high schoolers as part of it was called Mission Bit. It was a free after school program for public high school students in San Francisco. And I mentored a few classes and taught my own class. And I started with Scratch because I like Scratch. And there's this one particular moment I remember where I kind of gave like a 3-minute introduction to Scratch. It was like, here's kind of generally how it is. There's the screen on the left. There's these blocks on the right. You put the blocks together, do stuff. And then I just told them, okay, go do the introduction. It's like kind of a sidebar thing that just pops out. Just kind of go through the step by step. And then once you're done, we'll come back and like figure out what to do next. And they all completed it within like 30 seconds to a minute or something like that. But then something interesting started happening, which is they all started just spontaneously messing around themselves with no direction from me. I didn't tell them to do that. I didn't even suggest it. They just started making things on their own. Like I would call it productively messing around. And to me, that's amazing because I had this insight right after that, which was like, wait, if this was JavaScript or, whatever other programming language or environment, it would have taken them over 6 weeks to get to even close to the same space. So to me, something important about Scratch is that it took what could be a like 6-week or 2-month or some really long amount of time interaction and smushes parts of it down to like a minute or a couple minutes. And to me, that's really a function of its UI. Like it really pushed down whatever that beginner learning curve is to what's probably the bare minimum or close to it.
And so, how did it accomplish this? Would you like give the credit to the like no syntax errors, the shapes? What gives Scratch the magic?
That is something I may write an entire essay on someday. I think there's lots of really important parts, not just in UI, but also in like the community aspects of the Scratch programming experience and the emphasis on doing things that children authentically find interesting in the in the realm of Seymour Papert and these like, or Piaget, and these like people who are focused on what children find meaningful. But just from a UI perspective for the moment, I think having a toolbox of options is really important. I think having the blocks that you can just like drag out and are just kind of objects instead of having this like blank text screen where you can put anything, and having like a kind of good starting point of like, here's a character and here's things you can do with the character. Give it like a pretty low on-ramp, I would say, or a low floor, as Mitch likes to say, a kind of easily accessible to beginners experience.
Yep, I agree. I don't think it's paralleled. It's the best in terms of the low floor. So I think now is a good time to switch gears a little bit and talk about your time at CDG, and then which turned into Dynamicland. But first, I'd be curious to focus a bit on CDG because, as you said, it is kind of a secret organization that now doesn't exist anymore. So I'd be curious, and probably listeners too, about like kind of what it was like there, what kind of things you and others worked on.
Yeah. So it was a lab in San Francisco from, I think, late 2013 to sometime in 2017. I don't know exactly when it officially ended. it was the San Francisco lab was a building in south of Market, Soma in San Francisco. It's this beautiful building that we found, and it housed several of these research groups of the communications design group, which was basically, in my understanding, Alan kind of rounded up all of the resources to make a research lab in the style of Park back from the 60s and 70s and 80s. And so there are several groups within that was CDG, as kind of Alan, kind of head of the organization, but not actually in power, just kind of maybe spiritual leader or something like that. And he...
Make it sound like a cult.
It was a little bit cult-like, and especially because it was very radical in the sense of there's these several different groups led by different PIs. There was my group that was headed by Bret Victor. There was John Maloney's group who worked on a kind of successor to Scratch. There was Vi Hart's group, which was working with VR. They were called Ella VR. And there's Alex Worth's group in LA, and he was working on a lot of different kind of future of programming ideas. And I think Yoshiki was another group, although he was in LA and often worked with or around Alex Worth's group. But there's these several different groups, and they're pretty much autonomous, but able to communicate. Yeah.
Cool. And so what kind of stuff did you work on while you were there?
So the kind of dictum was Bret was really interested in he did the Media Lab talk, which was, do you remember the name off the top of your head?
Oh, that was such a good one. Was that drawing dynamic visualization? I don't know.
Oh, no, it was Media for Thinking the Unthinkable.
Of course.
So that was Bret, as I view it, that was kind of Bret looking at his past, 5 years of work or more and saying, okay, what is all this stuff he just made? And what is it pointing to? And it was pointing to him to this kind of really new idea, which is now what became Dynamicland, but this like really big set of ideas around what dynamic media could mean, and which is not a thing on a computer screen, which is not a thing that is like kind of inheriting old ideas of how media works, like static media, like paper-based media, things like that. And so Bret established this group to try and work in this new vein of like really wild, really new radical ways of working with dynamic content, dynamic media. And the group was called the Dynamic Medium Group. We didn't know what that meant. We had Bret's work as a kind of template, and he had published I don't know if you've seen this document, a floor plan and research agenda.
Yep.
Is combined. Yeah.
Yeah, very long.
That's definitely
long horizontally.
Yeah, it was this huge poster. Basically, it started as a PDF, and then he made it a poster because it wanted to be a poster. Is how he would say it, I think. But yeah, it's this giant document trying to lay out like these different aspects of human experience and human media, and trying to capture things about how media today did not work well, and how it could work well in the future.
Yeah, it's a beautiful document. I find it very inspiring.
Yeah, and that was the kind of agenda of our group, is to try and figure out what that actually means, or to start making examples, like little steps or big steps towards whatever this dynamic future could be. Maybe a future that's not so isolated to rectangles. That became one of the big like selling points, I think, of the vision, which is, why is all the computer stuff in this rectangle? it kind of makes sense. But like, we have this whole world to work with. We have these bodies. We have such keen social senses. We have all this like stuff that is not supported at all by the dynamic medium as it exists today. So
it's true. Yeah. Flat rectangles are flat and rectangular.
Right. And Bret had his essay about the future of human interaction design. I forget.
Yes.
Yeah, something like that.
That's a good one.
Where it's like, wow, we have all these hands, and these hands are amazing. Yeah. Why aren't we using them?
Sometimes I think he's at his best when he's complaining about stuff or like ranting. like his learnable programming essay is also one of my favorites. When he like takes something in particular and is like, this thing is so the opposite of what I think the future is.
Yeah, I like that kind of style of. Bret has made several things that I've seen in person that are like, yes, more of this, and no, not this. And often they're the form of pictures. So when it's like a bunch of people hunched over their laptops at not looking or talking with each other, he goes, no, not this. That goes in like the no column. And then it's like a bunch of people cooking together and all like sharing, a common space and working together and like looking at things together and collaborating in a more humane way. That goes in like the yes column. And I've seen like several of these kinds of yes, this, no, not this kind of format. I think it's just a helpful way of having like a bunch of deeply felt principles, but no concrete way to express them besides no, not that. And oh yeah, something like that.
So hearing you describe kind of the agenda of this group, I'm a little bit surprised because I didn't realize how like Dynamicland his group at CDG was. I didn't think you guys got 3D physical reality stuff until Dynamicland. So it like you guys is my new understanding more accurate that you were like building precursors to Dynamicland at CDG?
I think yes and no. So that is the dream and that was the vision. But a lot of, especially the early things that came out of our group and CDG in particular, were things that were more in line with Bret's work, pre-2013, I would say, or, like 2013 and before. So like those were his main set of essays and videos around future of programming and new expressive artistic things and dynamic graphics and explorable explanations and things like that.
Got it.
And so a lot of the things that I and many of the other people did were those kinds of projects. So that's where I came out with Legible mathematics, and that's when I came out with a interactive multi-representation viewing of a civil rights documentary called Eyes on the Prize. And those were kind of in the spirit of explorable explanation, things on the screen.
Totally.
But eventually we started getting, Bret got more and more into these ideas about dynamic physical media, so media outside the screen. And he was kind of like wanting to like pull us along with him, is how I think of it sometimes.
Awesome.
And so then we started making, it started gelling together when Bret and Robert Oxhorn created the kind of precursors to Dynamicland, which was called HyperCard in the World. And that was a system like RealTalk, which is what powers Dynamicland, that allowed us to hook up lots of different inputs and outputs, like cameras and projectors and processors, and scatter those throughout our entire lab space, and then create like demos or experiences that could kind of talk with each other. So you could like we used a lot of laser pointers at the time. So like you could laser point on one wall, a thing on one wall, and it could affect something in a different part of the room because it was all one operating system. And that's when the Dynamicland-like ideas were really starting to take off.
Cool. Before we continue on that timeline and get into like the Dynamicland stuff, I want to talk a bit about your Legible mathematics essay, because it really is one of my like top favorite essays ever of all time. It's just amazing. I put it up there with like, learnable programming. It's like, I think in my mind it's like almost an extension of that essay. So I kind of want to first acknowledge you for it because it's so great, and then also get
oh, thank you.
Get a sense of from like me wanting to produce content that's as good as it. Like, I want to kind of hear about how the ideas kind of came together and how long it took to work on it, and like advice you'd have for writing really amazing content like that points towards the future of programming.
Oh, that's complicated now. It was not as complicated when I wrote that essay, but my ideas have shifted and evolved as I've kept kind of working on this stuff. So for me, there was a bunch of things that I kind of felt awkward about in programming that I suspected did not have to be as awkward as they felt. And Legible mathematics to me was the first kind of forays into imagining in this very, like you said, learnable programming. It's pretty much modeled off of learnable programming, the essay. Kind of foray into different ideas for working in a particular domain. And I was kind of getting this idea that something that was annoying about programming was this very symbolic way of working, which Bret has talked about in a lot of different ways, which I think is great. But I was trying to explore, what is it about these symbols, and is it easier to understand how something is working if the symbols are augmented with like a more concrete thing, I would say, a more concrete representation. So like you see mathematical symbols and it's just like, that looks like a bunch of symbols. What does this mean? But then maybe you see examples of like the step-by-step execution of that mathematical formula, and it's like, oh, okay. That's probably a little easier to understand because you can kind of go back and forth between the symbols and the concrete representation. And I ran into this like many times, both while programming and in math class itself, where I was like, what? This feels weird. Like those symbols could mean anything. They mean a very specific thing often, but I don't really have a good sense of just coming into that, what that is, what it's actually doing, or what it actually means. So basically I brainstormed a bunch of ideas, which most of which went into legible mathematics, about different ways of representing arithmetic such that you actually see what the data is instead of just having like the arithmetic. And I kind of got into the like, what can we get just from looking? Like how can we design a mathematical expression so that just by looking at it, we can get a whole bunch of understanding of how the structure of this thing is working. So that was really directly inspired by not just learnable programming, but also Magic Inc.
Of course, yeah.
Because to me, a lot of what Magic Inc. is just about, the eye is so much faster than the kind of logical, thoughtful brain.
Totally.
So being able to like put the kind of understanding in the representation itself, I thought was very powerful. And then once you had that, there's a bunch of interactive things that one could do too, like what if scenarios, or seeing inside what each subpart of the equation. And so that was just to me, that was a kind of early exploration of those different ideas, many of which I'm still kind of hammering on today.
Yeah, and I want to get to that in a second, but I just want to acknowledge that I think you do a really good job in that essay of exemplifying the thing we talked about earlier in this conversation from Bret Victor's Magic Inc., the interaction considered harmful. You show like there, you have one visualization where you can expand a term to see how sub-expressions are evaluated. So that's kind of like an interaction-based approach. But then you show like another way to view sub-expression evaluation is just in line right underneath in the kind of a smaller, subtle view. It's kind of hard to describe over audio, but I think you do a really wonderful job of applying Bret's principle. That like eyes are very fast and efficient. You don't need to like add any interaction to make it better. It's actually better if you do away with that.
Yeah, and maybe instead of better, I would modify that to be like it has certain advantages depending on what you're trying to do.
Of course.
Yeah.
So I guess one question is about legible mathematics. Is like how much of it do you see as being about the like drag and droppy nature of it as opposed like versus like textual syntax, or is it like really not about that at all? And it's more about like what do these symbols mean?
Definitely the second part. What do the symbols mean?
Got it.
Yeah. To me
I sometimes got confused. I thought it was about both.
Yeah, for me it's a lot more about the kind of understanding of what the symbols are doing, and that has been a theme that has followed me throughout my programming work, which is it feels kind of unreasonable to me on a deep level that there's, you know, these symbols are doing something and it's totally understandable what they're doing, but we don't really get any help from the programming environment trying to like help us tease out like know exactly what he's doing or giving us some feedback, especially in real time, because it's, you know, quite often I have the experience programming where something happens, you know, 10 lines past where a bug has happened, but don't realize it for a long time. And then I have to go back and like I lose all the context, and a lot of these bugs could have just been caught immediately instead of having to wait a long time to do it, to catch it.
Mm-hmm. I guess just to play devil's advocate, I was recently rereading No Silver Bullet by Fred Brooks, which, you know, it's a great pastime for people like us to reread Fred Brooks. And he argues that software is inherently unvisualizable because it's so abstract. And sure, you could take simple symbols and show concrete values that they represent, but once you get complicated data structures and abstract data structures, it's hard to pull this trick. So how would you answer, like, how would you respond to that idea?
I think that saying software is inherently unvisualizable is a kind of self-fulfilling prophecy, where it may in fact be that lots of software or parts of software, especially in programming system, have alternate representations which give us better information about how a system works than the very symbolic word-based or like string-based or graph-based, maybe is another way of saying that, complexity of software systems. And I think it's partly true that software systems are just enormously complex, especially big ones like Microsoft Word it's probably like 20 million lines at this point, like some huge number of just straight lines of code that, as Alan likes to say, if anyone tried to read all of that code, it would take them a lifetime. Like no one can actually read that many lines of code, which if not one person can keep a thing in their head, you know, there might be some problems there. Or maybe not just one person keeping their head, but like it's just a huge amount of information. And trying to cut back on that complexity, I think, is a really important task. And one way we have of doing that is by working with representations, and representations that give us certain information that might help us understand something in an easier or more complex way.
So you're saying that if we had better representations, they'd lend themselves better to visualization? Is that
I would say it's a research project that I think is quite interesting and quite worth doing, to try and to make software systems less complex or easier to hold in the human mind. Maybe is another way of saying that. I think representations are going to be the big one that helps us do that. And those could be visualizations, but I don't exactly mean visualizations. Like text is a visualization, for example, or representation. But code is a particularly not great representation in a lot of ways, especially for human understanding. Like, a lot of programming languages were designed for kind of the machine first to run and the human to understand second. And a lot of what my work feels like it's about is kind of trying to do the opposite. Starting with, okay, what is a good human way of understanding this stuff? And then let's try and make a programming system out of that. Is that possible? It may not be. But.
So in like the Bret Victor inventing on principle sense, I kind of wanted to give you an opportunity to rephrase your principle. It's because it sounds like that's kind of what you're saying, that something in what you just said is your principle. Or maybe I'm putting words in your mouth.
Oh, I see kind of what you're saying. Let me think about that for 1 second. I'm actually not super principled about this. I would say that my heart breaks when people aren't given the potential, or when people's potential is shut down. And I see that happen a lot with programming in particular, because of bad environments, bad design decisions, bad languages, things that aren't meant for humans, or not meant make it easy for humans who don't already understand programming or already have a super logical mind to kind of wrap their minds around. So for me, it's a lot more about the compassion of not wanting to see people suffer like that, not wanting to close people down to programming just because they need to install some Python environment, and then somehow that doesn't work. And beginnings are so fragile, and so wanting to really kind of hold that, kind of getting the sense of like a baby bird, really hold and cherish and give the most possible support to. That is more where I'm coming from, rather than a principled approach.
Yeah, I could see that. I have a clearer picture. It almost to me like the installing of packages, and there was another phrase used, something about like having to know programming, or having to deal with random programming artifacts. To me, the phrase that encompasses a lot of those things is incidental complexity, or machine complexity, versus the things humans care about. So I like the way you kind of put this common phrase of incidental complexity in terms of very human compassion and nurturing.
Yeah.
I don't know. I like that.
Yeah. For me, that's the most important thing. It's compassion. And all the kind of creativity kind of runs from there. Because otherwise, how am I going to know what I'm working on? For me, I struggled a lot with how do I figure out what is a good thing to work on? And if I just come back to compassion and really, what do I want for human beings? Then I have a huge amount of energy to work towards human benefit if I just connect with that compassion.
Mm. Cool. I feel like this is an interesting transition point to talk about Flowsheets, because I vaguely remember you talking about some problems that you were working on or saw others working on, and you thought that you could build a better tool to allow people to work on those sorts of problems, and that's kind of how Flowsheets came about. In particular, I remember you mentioned that it was like watching Jonathan Bloom programming that got you inspired to do Flowsheets. And I know that your obsession with watching Jonathan Bloom program is also like an interesting thing to talk about. So I thought I'd start there.
Oh, Jonathan Blow. Yeah.
Blow,
yeah.
Sorry. Yeah. That's the name.
Yeah. So Flowsheets, I worked on it quite a bit at CDG. That was another one of the projects. And I made a couple different prototypes. The first one was in collaboration with Alex Worth, most notably, who helped build a lot of the first thing. And more or less, this was me understanding that I had a bunch of different kinds of similar programming tasks that were a lot about data manipulation that felt really not easy for me to do in like Python, which is the language I use quite a bit, or JavaScript or something like that. And I imagined it would be a lot simpler if I just kind of got direct feedback, like I type a line and then do a thing, and it does a thing, and I see if it works. And then if it does work, I can go on to the next thing. Otherwise, I got to modify the thing I just wrote. Or I can like try things out. Like I could have just imagined doing those kinds of tasks in a much more fluid way. And I took a pile of these programs that I had already written in Python and redesigned them in mockups at first, and then in a separate programming environment to see what it would be like what it would look like and what it would be like to program if I was always looking at data as I programmed. And I never actually didn't have the option of not looking at data. Like I always had to be looking at concrete, something did something, rather than normal programs, which tend to be very abstract or can be very abstract. And that's where Flowsheets came from. And I made the first prototype at CDG and the second prototype later when I left in, I think, late 2016 or early 2017, I think is when I made Flowsheets, version 2. And actually, I would like to say one thing before I get to the Jonathan Blow thing, which is one important part felt like I really over-designed the first system. Fred Brooks has like the second system effect. I would say actually I did that the opposite way, where I really over-designed the first one. It was like imagining how every little thing was going to work. And then in the second prototype, I was like, you know what? I couldn't actually make any programs. Like it wasn't fun to make programs in that environment. What would it be like if I just like threw away a bunch of my ideas that I thought I cared about and just tried to see what is it like to program with data? Even if I have to like type in little bits of Python, that's fine. Just I want to see what it's like to have data. And it turns out it feels really good, especially when you're doing like kind of data-oriented, like data transformation tasks. And I made like a couple dozen programs in Flowsheets version 2. And it feels great. It's like become my preferred programming environment at this point. So if I have a task that's very data transformy, then I prefer to use that because I can see what's going on. It's like very, very clear.
Yeah, and it's quite a claim. I'll just put that out there. But I will also put out there that it's a very easy claim to believe in once you've watched the Flowsheets videos. So if anyone out there who's listening to this hasn't already seen the Flowsheets videos, I highly recommend it. And you will believe Glen's claim that it is a preferred programming environment for data intensive tasks. I endorse it.
Thanks. I don't actually have a claim about other people wanting to use this environment. I just have my very pure claim is that I really like using it. And
Yeah, well, I guess what I'm trying to say is that I don't believe you're like deluding yourself and you just like something because you made it. I think that like most people it would be like a preferred environment for most people.
Yeah,
Or at least for me, I can say that.
yeah, it feels good to use, and the like getting direct feedback on the data as you create the program. It feels kind of like a no-brainer at this point to me. This is like, oh yeah, of course we need something like this. This feels really good. Like, why would you not have this?
Yep.
Instead of, like, a lot of times I have to like guess what my program is going to do, and then it's like hard to get the information if it doesn't do what I expected to do. It's even hard to tell if it did do the thing I expected to do. So just getting the direct feedback, it feels great. And I think there's a lot of potential there too. I'm actually starting a software business based on Flowsheets version 2, which tries to make a more, I'll say, consumer ready, like more accessible. So you're not having to type in Python, for example, but you could do more like drag and drop kind of things.
Oh, interesting. I feel I like not to like, you know, I'm sure you know this better than I do, but I liked Flowsheets version 2. You type in Python for the reasons that you said, you know, like you can still do a lot, kind of like in Excel, you type the equal sign, you type your little formula, you know, like you don't need, it doesn't need to be much more polished than that.
Yeah. Using,
anyway,
the one of the big problems, or the maybe parts that are incomplete, is that a lot of times you want to like have the program affect something in the world, like make a network request or write a file to a disk or save some kind of thing.
Yeah.
Like there's a lot of things that you'd want to do, or like run on a server every 5 minutes, things like that. And Flowsheets was not capable, or the prototype I made was not capable of doing any of those things. There are probably ways to do that, but I didn't develop the prototype to that point.
Got it. Well, so that's actually something that like leads me to something that I've been working on for a while. So I wanted to get your thoughts on it because it's very related to Flowsheets. So Flowsheets makes a lot of sense for like one-way data transformations. You like import, like in your examples, you import a dictionary, you filter out some words, and you map some words. That all works beautifully, and that's a lot of what programmers do. So that makes sense. But there are some things that programmers do, like reactive systems, where they're like cycles. You know, data is updated, like shows you some view, and then people interact with the view, and it updates some data. That interaction thing, but Victor doesn't like so much always. Or just like network requests. Like there are things that are more real timey that aren't like one way mapping. So do you have thoughts on how you would keep the concreteness with things that are kind of flow through time?
Yeah, I think this gets back to me for the Jonathan Blow video. So Jonathan Blow is the programmer who made Braid and The Witness, these two amazing games. And he's also the designer of the games. And he sometimes does programming streams. And he like shows him making the game engine for his games. And I got very interested in watching him program for like a few weeks of last year. I was kind of watching him program obsessively because I think he is probably one of the best programmers that I've seen work. He has this like very sharp mind. He knows his code really well. He has like a really good eye for subtle details, like how things are mapped in memory and how that's going to affect performance. And he has pretty good senses of when there's a bug, what kinds of things will be the roots of those bugs. He still has a lot of issues tracking those things down, which I think to me is an opportunity as a designer, saying, okay, here's something even one of the best programmers that I've ever seen has issues with. What can we do to help this person? And I don't know how to do that. I have one prototype in I haven't that's like, like 20% finished or something like that, that I may try and submit to live this November.
Oh, sweet. I'm planning to be there,
great.
so I will see you there.
Yeah, I'd love to see you. Yeah, it's kind of a mix between a REPL and a debugger that lives alongside your code editor. And this is basically trying to do the opposite of Flowsheets in some ways, or bring the best parts of Flowsheets into a larger code base. Because if you visualized the data in every line of code in, a 40,000 line code base like Jonathan Blow is working on, then you're just not going to be able to understand what's happening. It'll just be too much information. It'll be a lot of irrelevant information. And so that, to me, I began to wonder, like, how do you bring some of these really nice feelings of Flowsheets, like the kind of direct feedback and this good insight into data with live, being able to try a lot of stuff out very quickly. How do you get some of those benefits into a really large code base? And so that's this idea for kind of REPL or debugger, or I'm calling it replugger. We'll see if the name sticks.
Replugger. That is an elegant name.
Thanks. But I think it's important because here's this expert programmer who still has lots of problems programming. Like, he is extraordinarily smart and gifted and works really hard to do all this, yet even he's having problems. So for me, it's not just making programming better and more accessible for beginners, which I think is really important, like really, really important. But I'm also somewhat interested in this question of how do we make experts better?
Yeah, I totally agree. And I am also someone who like oscillates on both ends of this problem. Like, how do we lower the floor and also like raise the ceiling? I don't know if raising the ceiling is quite the right metaphor, because we don't want to increase what people can do. We want to kind of like increase like their ability to do the things. I don't know. So yeah, I agree with you. They're both interesting problems, and I think you and I probably are in the same boat in that we hope that like there's like kind of you could use the same solution for lowering the floor and raising the ceiling, if that makes sense. Like, you could build something that Jonathan Blow would like, and it would also help new programmers at the same time.
That's quite possible. I worry about the kind of competing design considerations in that sense. So yes. For me personally, yeah. I'd want to work on maybe one or the other, or chunks
one at a time
of each. But yeah, I share that vision. Like, an artist uses a pencil and a 4-year-old uses a pencil.
Totally. I guess the opposite side of that argument is like a lot of professionals have professional tools while beginners have beginner tools in other industries. Like, kids play with shovels, but like adults use forklifts or whatever.
Right. There's like an increase in capability that can come.
Yeah. And like complexity, like kids use iMovie, adults use Final Cut Pro or Premiere or whatever. But I guess, to criticize my own argument, iMovie and Premiere and Photoshop 10, or not Photoshop, Final Cut 10, all look very similar. Like, you just add a few knobs and you get the more complex interface. So that could be kind of the solution. Like, they look similar, but the adult one has like a little bit different design criteria than the kid one.
Yeah, and I'm a little wary of using Final Cut as the kind of end all of movie production software, because there's huge amount of problems with it. As I used to know someone on the Apple design team who was designing the next versions of Final Cut. This is one of the friends of the lab of CDG. Mm-hmm. And hearing some of the stories about how people use it in Apple's internal design process, it is far from perfect, is what I'll say.
Totally. Yeah, well, Final Cut 10 was kind of like a disaster. The first version of Final Cut 10, everyone left and went to Premiere. Because I was a filmmaker at the time. I was like in high school, but I was like doing film stuff. And so we all switched to Premiere. But then Final Cut 10 kind of like, like improved enough that I think a lot of us switched back. But I'm not really a filmmaker. I was just a high school filmmaker, so I don't really know what I'm talking about.
But still, and to maybe, I have like little versions of Alan Kay and Bret Victor in my head now after studying their work for so long. But I feel like an important part is to study the heights of human expression. And, they're not just exclusively like accessibility is still important, but also trying to understand like what are the kind of greatest things that humans have made, and is it possible to support humans in making those great things? And like what kinds of things would they need?
Totally, like expert tools, like how do we empower scientists to like solve global warming? I know Brett's talked about building tools for that kind of thing.
Yeah, exactly. And I don't have too many opinions about that, but I think it is worth looking at the kind of amazing expressive qualities that humans have, and trying to support that in all its glory, from its beginning stages to its completed stages.
Yeah, I'm with you. I feel like Brett and or Alan might say that the extremes are the best places to work. Like allowing lowering the floor for kids, that's great. Raising the ceiling for experts, that's great. The middle chunk, the people who are working on Snapchat, like we don't need to make their lives easier.
Well, yeah, because they're going to make Snapchat. They already made Snapchat. They already made Final
That's true.
Cut. Like from a research perspective, anyway. Not a business perspective. Those are kind of, already done, and people are going to continue making things like that. But
whether or not we help them.
And so there's, precious few of us working on, pushing, it feels a little grandiose, but like, really kind of pushing the boundaries of what UIs can do and who can program and how they program. And I think that's important for, it's hard to see computers getting any less pervasive than they are now. And we kind of understand that there's an inherent power that comes in programming, whether that's through expression in Scratch or through like simulating climate models in Python or C++ or something. And, I've actually gone and talked with a scientist who's studying meteorites. He's like one of the foremost meteorite scientists that happened to be studying at UCLA. And I asked him about his kind of software tool chain, like how he did his thing. And, if you ever want to be inspired, go talk to a scientist who does any amount of programming or data munging. It is incredible, the kind of horribleness that you'll see, like the kind of spreadsheets that are chained together with people manually updating things, and it's kind of amazing that the science is actually able to get done given the kind of their bad tooling, their bad tools.
Yeah, that makes a lot of sense. I have a friend who's a scientist, and he just uses Python or maybe IPython. But, unsurprisingly, he's able to make it work because he's a genius. So like, it doesn't matter that the tools are so bad, or maybe I flip it. Because like the tools for doing science are so bad, in order to be a good scientist, you have to be a genius.
Yeah, I think that's a big part of it.
Yeah, so it'd be nice if more people could be scientists. One thing I wanted to touch on that we kind of skipped over is I asked the question of how we make things that are less obviously visualizable, and so you talked about your what was it?
Replugger.
Replugger.
A REPL plus debugger.
Replugger. Replugger. Got it. I missed the P. Replugger. It's almost as hard to pronounce as your last name.
I'm just going to keep making you say it. Replugger.
Replugger. Okay. So that's, I think it makes a lot of sense why you'd want to build something like a replugger. But the tack that I usually take when trying to visualize the hard things in programming, or the tact I'm taking now in my work, is I'm just trying to restrict the model of what's allowed in programming, like get rid of mutable state, get rid of side effects, like kind of make it Haskell-y almost, because my contention is that when you really restrict things, like when you restrict the dimensionality of programming, the sorts of things you can do, it increases it, it allows it to be mapped onto a 2D plane better. So I just thought this would be a good time to see if you had any thoughts about that approach.
Feedback. One thing I've thought about lately is that in modifying programming, there's like a lot. There's at least from my perspective right now, there's only two tacks you can take, and one of those is change the model of programming in various ways, like you're doing with mutable state, or when someone invents a new language, they're at least slightly tweaking the model of how a programming language works. And you can also change the UI, or the way someone interacts with that model. And that's the place that I've been working mostly, which is trying to change the UI. So right now the UI is mostly like a text editor or something like that. And the representation, there's another part of the UI, is a bunch of code, a bunch of text, or a bunch of words and symbols. And so the thing that I'm interested in doing is how can we, it kind of doesn't matter which model, to me, it doesn't matter which model of programming someone uses. But if it's well represented, or if like it might just be obvious what the model is doing if given the right representation. And the one example I have of this is a friend was telling me that in Perl, when you iterate through like a hash table or something like this, I forget exactly what data structure was, it does it by mutating a pointer to the thing that it's iterating over. And so if you break out of a loop, then that pointer is still in the same place, so it didn't get reset. And so if you start looping over it again, it will start from that place.
Oh boy.
And yeah, that's what a lot of programmers say when they hear that. And to me, that might be a reasonable design decision. Like, I think at this point we've learned that that's kind of, that's not great. Like that's kind of a bad model. But I could imagine that actually not being a terrible model if somehow it showed you as you were doing this, like, hey, it is mutating this thing and it might get stuck in a place. And if it could just show you that, then my contention is that would be fine. Like, as long as the programmer is aware that's what the model is doing, then, hey, we're good. Like, they know it does that, and then they can work around that or use that to their advantage or whatever they need to do.
Interesting. I'm with you. Where my disagreement is that when you have something like you were saying, like Microsoft Word, the 20 million lines of code, and you're stuck with a model where, sure, you can understand it line by line, and I can tell you what each line is doing visually, or like I can give you the values of each of the symbols, but you still have to go through the 20 million lines, which is going to take more than the years you have on this earth. So constructing visualizations that allow for like greater comprehensibility, I think, is important for like regular people to be able to understand complex software. What do you say to that?
I'm glad you said that. So to be clear, I agree that your tack of working with the model, I think that's great and important, because this is like the argument about Roman numerals versus Arabic numerals for multiplication, where this is a little bit of a.
I can't tell if the Roman numerals versus decimals is is the model or the UI part? I can't tell which way you want to take this.
That's a good point. It's not. It's kind of both. But I was thinking of the model. I could see how that's confusing, actually. But yeah, I think changing the underlying model is quite important because the model is like the main way we have of understanding a thing. And more powerful models just like simplify things vastly, or can do that.
Leverage.
But yeah.
So given that you're with me there, you would the reason you're working more on the UI is why?
Because almost everyone is working on the model. Is one part of it.
Sorry, I think you cut out.
Oh, I was saying, I think almost everyone is working on the model.
Oh, okay.
That's why every new programming language gets created. That's why people get really stuck in compilers and type systems. And there's a lot of talk recently about like React and non-mutable state and all this stuff. And I think a lot of that's good, but there's a lot less work in trying to evoke what a model does as opposed to the model itself. And so to me, that's an important just kind of, it's actually quite easy to come into this field and start working on something like that and discover something completely new because no one's ever done it. It's just a very, not really like a field yet. Totally. But back to your point about Microsoft Word, and 20 million lines. Yeah, so that, to me, that's part of this research is, I wouldn't argue that line by line showing data is a good way to understand what Microsoft Word does.
My apologies for this.
Oh, no, that's fine. Just being clear. But I would say that, and this is partly what Alan's STEPS project was about, which is different ways of organizing that software may make it a lot easier to understand in the same way that, like, this is again from Alan, like the pyramids of Egypt were a bunch of rocks stacked on top of each other in the kind of the most naive way. And it took a lot of suffering and slave use and human power and human lives to create. Whereas something like the Chrysler Building or the Empire State Building, went up in several months, and it's, like a fraction of the weight. It took fraction of the time. It's almost all usable space, as opposed to the pyramids, which had like a tiny amount of usable space. And something happened between the pyramids and the building of the Empire State Building that we kind of somehow got a way of organizing materials and having new materials that made it way more efficient, way easier to do, way more doable. And there might be something like that for software. And this is, to me, I don't have any good like pointers yet because this is so new. Like, I can't really argue that this is definitely the future, but I think trying to make these software systems more legible, I think to me that's a big part of it, is understandable. Because if you can understand something, it's a lot, you can change it, basically.
Yeah, of course. I'm totally with you there. So I'm glad you brought up the STEPS project. To dig in more, to me, the STEPS project is kind of more on the model side. Like, it looked like a lot of what they were doing was creating new programming languages models, like that vector graphics library that they created, like Nile, and that was like a tiny amount of code but was super expressive. Like other abstractions, as opposed to like legible mathematics type of visuals or Bret Victor visualizations. I don't know.
Yeah, I think that is almost all in the model. But then, Bret came in and made the representation, the UI for the model. Because as he pointed out in Media for Thinking the Unthinkable, that if you read that code, it's just a bunch of symbols. But there's actually a beautiful underlying model to it, apparently. And to evoke that model.
I've tried to use Bret's tools to get at it, but I wasn't able to do it.
Yeah. But to evoke the model, there's some like UI that isn't necessary to like show here's what the model is doing. Here's why this thing is happening.
This is fascinating because I really now I could see that I can contextualize my work as really being right on the center. Like I'm trying to create models that lend themselves well to being visualized. So like I'm constantly going back and forth, like trying to create a new model, see if it's visualized. And I'm realizing how unique that is. Like people usually work on one side or the other, but I guess there's some people like you and me and Bret and Jonathan Edwards who jump back and forth.
Yeah, and for me, I would say I mostly work on the representation and UI side. Like to me, any programming model is probably fine. Like it could be fine depending on what you're trying to do. But yeah, trying to understand and evoke what the symbols are doing or how the model works, or that there's a model at all, because most beginners don't even get that when they come into a programming language.
Yep. Cool. Yeah, this was a great little tangent discussion. But I think I want to move on, just in the interest of time, to talk a bit about Dynamicland and Laser Socks and your adventures there.
Sure.
Cool. So let's see. I don't remember where we left off the conversation in terms of how CDG turned into Dynamicland. I feel like maybe Laser Socks is a good place to start.
Oh, yeah. And I realized I didn't really describe CDG super well. So like the one sentence summary is that me and the handful of other people in the group all made like dozens of prototypes of, from little things like taped together to kind of more software things, trying to get at what this dynamic medium thing that Bret was describing might be. And so we had HyperCard in the Worlds, which was set up throughout the room as a system that we could kind of play with and add things to. And one of the researchers, Chaim Gingold's, decided he wanted to have a game jam, which is like a one-day kind of thing where we all just use this new system to make games in it. And that was really fun. I should just say, like, we all, like, I think about 10 people in total all created a bunch of different games in the system, all kinds of different games. And it was interesting. They were all multiplayer because they're all kind of out in the world. We didn't, like, say that at the beginning, but they all just kind of became multiplayer because that's what you do when you're in the physical world, is you interact with other humans. Generally. So we had all these multiplayer games, and that's where Laser Socks came from, where we had a lot of the system used laser pointers to do interaction. And so we could like point to something across the room to make something happen with the laser pointer. And I was like, oh, there should be like a dueling game where you like shoot lasers at each other. But that's probably unsafe. You'll probably hit people in the eye. And these were like pretty high power laser pointers. So I was like, you can't shoot at them. Oh, what if you just shot it at their feet? And so that's where the idea for Laser Socks came from, which is a game where you stand on these two game pads and shoot lasers at the other person's feet. And they try and shoot a laser at your feet. And once they hit it, a camera detects that they hit it and it fills up a bar. And once your bar is full, then you've lost. So whoever has their bar fill up first loses.
Interesting. That makes a lot of sense. That you thought like laser pointers and eyes are bad, and then like feet are kind of far from eyes.
Yeah. Yeah, and
so
go ahead.
I was going to say, so it's detecting that the laser pointer is not on this? How is it detecting the laser pointers on the socks?
This is actually kind of one of the magical things about. I had a conversation with Chaim about how do you get the system to detect when a laser hits a sock, and somehow we both don't claim credit for this idea, but somehow this idea happened where, because the cameras had their exposure really low and we're basically just looking for bright dots, we could use that fact to have a black gamepad. And so when you shoot a laser at the black gamepad, it doesn't reflect very well because it's black. And when you hit, we had to buy a bunch of white socks. And when it hits the white sock, it lights up really bright and the camera sees it. And so once that happens, once it reflects off the white sock and it reflects bright enough for the camera to see it, then it detects a hit and increases your score.
Oh, so easy.
Yeah.
It doesn't have to like know where the socks are in space and where the laser is in space. It's just like, is there a circle in this square or not?
Exactly. Is there a bright dot in this particular square? And to make this system, it was incredibly easy. It took me an afternoon to build it, and I basically taped some trash bags to the ground, and then you use the laser pointer to like draw a rectangle around the trash bag or the gamepad, and then you say that basically tells the system this is an object of interest. And then it detects that object, and you can like do things with that object. Like if there's a laser within this object, do something. And so I had to write a line of code, or what would be a line of code. It ended up being like a dozen or a couple dozen lines, just because the system was imperfect. But like you could imagine writing one line of code, which is when a dot is detected in this square, or when a dot is detected on this object, because it's an object-oriented system, increase the score. And then the score, keeper thing just draws a rectangle, which is like draw a rectangle when the score increases. And to me, that was like an interesting, from the future of programming perspective or the future of coding perspective, that was like a really interesting I'll call it a discovery. It doesn't exactly feel like I made it, but like I could program this thing that's a pretty new and fun game in an afternoon with trash bags and cardboard and laser pointers and socks. And I could do that with like 2 lines of programming. And it like pointed out to me that there's like, there could be something real here, or something really interesting in bringing a system like that to a wider set of people. Like I wonder about the kind of creativity that would be unleashed if such a system like Dynamicland have made it out and had a good like corpus of information of like, here's the kinds of things you could make. Go nuts.
Yeah, I agree with you that Laser Socks really does kind of point towards something, like the ability to create multiplayer, fun, creative things very simply. There was an analogy someone used that I was looking for in preparation for this interview. I couldn't find. They compared Laser Socks to something. Like it was like the killer app of Dynamicland that kind of proved it. Do you remember what I'm talking about?
Bret. Yeah. Bret said that Laser Socks was our space war. And he was referring to Space War, the like classic, one of the first computer games that all the the ARPA researchers were playing and modifying and sending around. It was like one of these like amazing, this is like a really simple game about like shooting each other's spaceships on this really early prototype screens and stuff. But Stuart Brand wrote an article about Space War, about how like incredibly addictive it was and how people were like staying up all night to do it, and it was like a harbinger of like, here's something really new that computers could do that no one's ever really seen before. And that's the analogy Bret was making of like, here is like a kind of game that's really fun at Dynamicland, like in this new medium that is pretty simple, but it has this like interesting quality.
Yeah,
awesome.
I
don't know if I quite agree with that analogy, but I'm flattered.
Yeah, I can imagine Brett's giving you quite the compliment there. So yeah, I'd be curious to hear your thoughts, pros and cons, criticisms about Dynamicland. Maybe if you want to go into why you left, that'd be interesting too. What you think about the future of what Dynamicland tells us about the future of programming.
Yeah, so Dynamicland CDG started, it became clear that our funding was running out. And I want to say in a really quick aside that the funding was pretty innovative in that it was just given to us. It was just money given to us with nothing expected in return. As that's my understanding anyway. And that is the research model that Alan Kay would like to see more in this world of researchers who, have some interesting ideas to just kind of let them go and follow their vision. And at the worst case, you've paid their salary for a decade or something. And the best case, you get things like the internet or, interactive computing, or laser printers or all this stuff that happened back in the ARPA days. So it's a pretty small bet in comparison to like the huge amount of stuff that can come out of it. And I share some of that. So that's just something I want to mention. But back to CDG. So the funding was running out and the whole set of all the researchers could no longer be supported by that funding source. And so the dynamic medium group, Bret Victor's group, started trying to spin out and find different funding and kind of continue their research. And that's how Dynamicland got created, which is a nonprofit research group at this point. And they have a building in Oakland. And I was there for kind of the very last parts right before they kind of had an office across the street from the current building that was under construction. And I left around kind of when it was being designed and planned. And the reason I left was had really nothing. It was the group was switching roles a little bit to more the design and engineering of Real Talk. And to me, that wasn't so interesting. It felt a little bit more like kind of nitty gritty flipping bits than I cared about. Yeah, a little bit more engineering than I cared about. And also my interests were shifting from computing at that point anyway. And I was getting a lot more interested in, maybe I'll say, human happiness.
Yeah, you dropped the incidental complexity stuff and you just focused on compassion in its more pure sense.
Yeah, I examined my work really closely and I thought, what would happen if this work succeeded wildly? Like if it really took off and the work that I personally was doing, what would happen as results? And how would humans be affected? And really I asked, would they be happier? And I realized the answer to that was not really. I would like it if programming is more accessible and better for expert programmers. I would like it if people are able to make things like laser socks. I still think those are good and important. But for me anyway, they didn't really have the grab. We have, this is in some ways the age of wonder. We have these incredible things around us. We have supermarkets full of food. We're really, pretty cheap food, all things considered. We have amazing access to resources and plumbing, and we have this incredible entertainment and these amazing computers. And yet it doesn't seem like we've made a real dent in human happiness. So I wanted to work more directly on that. So I left to explore a bunch of things and decided I want to be a therapist. And that's actually one of the main things I'm doing now, to be a psychotherapist.
Yeah, fascinating pivot. My girlfriend and I like to say like hard pivot whenever we like come up with a drastically different idea than we were thinking about. So one phrase, so you use the phrase that like make a dent in the universe in terms of human happiness. And so that like would lead me to believe that you don't, or while you may want to do psychotherapy like in a one-on-one basis, there's like maybe some sort of like vague plan to scaling whatever you learn to achieve like large amounts of human happiness, or creating a methodology or something, or am I putting words in your mouth? Are you and trying to make a startup out of what you're doing? You're just trying to be a therapist for people one at a time.
I have some thoughts about that. I realize this isn't exactly about the future of programming, so I'd be happy to go back soon. But just to comment on that,
yes,
I think it's worth not underestimating how important it is that one person has found some happiness. Like, to them, in this like one lifetime, is actually, it's the most important thing to that person to be happier. I think that's what, we're all going for. And so I try and frame it, instead of thinking in this very like industrial, like, you've inherited a kind of scientific industrial idea that like we have to scale all of our efforts to many different people. And I think that's important and true in a lot of ways. But I'd like to do that. I don't know how to do that exactly for something so individual as therapy yet. I'm planning on working on it. But I also want to say that, one person's happiness is actually quite important, and not incidentally, that one person being happy affects everyone around them in very, very concrete ways. They're not even that subtle a lot of the times. And there's like a kind of wave that happens. So that is my answer to, or part of my answer to,
totally
scaling question.
And I'm totally with you. I just to kind of follow up, I just want to check. Do you have any vague sense of scaling? Like, I don't mean to say like to like as if I didn't hear what you said. I understand that helping one person, being a teacher or a psychologist has an enormous impact on the world. Just knowing you, I was wondering if you had any hopes or vague sense of some sort of takeover. I don't know, something.
Yeah, I do.
Okay.
Yeah, I want to bring happiness to everyone that I can, or help people find happiness, maybe is another way of saying that. And I would like to do that. I can't do that just by talking one-on-one with people. So I'd like to put an eye towards, or at least like some of my effort towards figuring out ways to help more people. Like, one idea, just to give you, is to work as a kind of in-house therapist for organizations, maybe as a consultant or like something like that. Maybe organizational therapist or something like that, which is a person helping the organization to achieve better results, just like a therapist does for an individual, and also working kind of individually with the people in organizations. So I think organizations are like the place of adult learning in our society, the kind of most common place, just like schools are for children. I think the workplace environment can be a space of the primary space of adult learning. And so I'd like to help cultivate a culture of, a growth culture or a personal growth culture within organizations.
Cool. Yeah, that's fascinating. I watched the first episode of the TV show Billions, and I think there was a organizational psychologist in that show. It seemed like a fascinating job.
Yeah, it's pretty interesting. I have not yet done much with it.
Yeah, totally. Okay, so to bring it back to programming, I wanted to give you the space to say like what you liked and didn't like about Dynamicland and how it points to the future of programming. If you had a few, like some summarized thoughts about that before we talk about one other thing.
Okay. Dynamicland. I am really happy that Dynamicland exists. I think it's great work and it's really worth doing. I'm really happy that Bret and the team have found the space to do that. Personally, my heart goes out to them, and I wish that the funding was easier. I've heard that it's hard to get funding for, it's like such a unusual kind of space that my understanding is that they're looking for funding a lot of the times. So I would really like that organization to keep continuing to do their thing, because I think Bret is brilliant. The team is brilliant. And I think it has a lot to say. I don't know if it has a lot to say about the future of programming necessarily. I think a lot of interesting programming things will come out of it. The team has been quite interested for a while now in making languages that are more like physical languages that sit on a table as opposed to code that is on a screen. And they also invented like a kind of operating system that is pretty amazing, real talk. That is kind of like an operating system kind of protocol, maybe programming language-ish kind of thing. So I could imagine lots of interesting programming innovations coming out of just the team iterating and working on creating the next versions of RealTalk and Dynamicland. And this feels a little... I'll say that something I worry about or wonder about is the technology at Dynamicland being matched up with the ideals of Dynamicland. Like, I think Bret in particular has had an emphasis on artists and inventors and scientists. And I think in Dynamicland that shifted a bit in order to be more about everyday people, accessibility, making sure that the community can be involved. I think that's really important for programming in particular. But I do wonder about the kind of like, what exactly is the technology at Dynamicland good for in some sense? Like, what kinds of human experiences does it facilitate? Is it just things like laser socks? Is it things like, spreadsheets or business plans? Is it things like community organizing? Is it things like political intervention, things like teaching, like lecture style? Like, I have all these questions about kind of how it's going to spread into the human world. But I'm more just excited to see where that goes. I don't know where that's going, and I hope it goes someplace good.
Yeah, totally. Me too. Cool. So the last thing I want to talk about is your current project. You mentioned that you're working on an interactive visualization of a library that you built.
Mm-hmm. Yeah, that's just the most current thing that I'm working on. I started it while working at the Recurse Center for one of their week-long batches in New York City, which I highly recommend. That place is awesome. Everyone there was really cool, and it was a nice space to work, kind of head down and just work on a thing for a week. So yeah, I'm working on this representation of a a JavaScript library that I ported to JavaScript from Python like 5 years or something ago. And I've never quite understood how it worked, even though I ported it. And yet it still kind of works. But every time I have to try and fix it, fix a bug that someone reports, I keep like running into like, wait, what is this doing? How is this laid out? Like, why is this code doing it this way? What will happen if I do this kind of thing different? And that's me, the maintainer of the library. And so I can only assume that anyone who tries to like understand how this code works is running into even more issues. And I think this is a big problem, is that for a lot of open source software, it's open source in the kind of, you can see the code, but you don't really have insight into like how the designers of the library were thinking about it, unless they have stellar documentation, but that's kind of its own separate thing. And it's basically just hard to read code and understand like what a thing is doing and why it's doing it the way it's doing it. And so
totally agreed. I feel like I'm kind of working on an essay about this exact thing. Like, code is open source, but who cares? Nobody can understand it.
Yeah. And it's useful, people do stuff with it, but like as soon as you run into problems with a library, it's just like looking into the code is a mess. There's just a huge number of problems with it. So I'm trying to make a representation of this library that's like a little bit of an interactive explanation, but kind of just shows the internal workings of the library, kind of like instead of like a black box, I think of like a clear box or something. Like, the library is its own kind of artifact, like its own separate thing, but within that, it has its own internal workings. And so I'm trying to just evoke those internal workings and really allow someone who like doesn't know anything about how this library works, not only to understand what the library does, but how it does it and how the different parameters work. Because this library has like some parameters that you can tweak that changes the behavior of the library. And you kind of can't really understand what they're doing unless you see the internals, because it's based on a mathematical model of cosine similarity. So basically, it just explains a little bit of the mathematical model, and then just shows both in these kinds of tables and interactive views, so you can change things around and see how the behavior changes. And there's lots of like pre-built examples that you can play around with to understand what's doing. And it also looks like a GitHub page. I basically saved a copy of a GitHub page and then just modified the kind of documentation part of the page, because GitHub doesn't allow you to like embed JavaScript in the documentation. So I had to like fork off a page, and it's kind of like a cheeky, like, okay, I'm pretending this is GitHub even though it's not, but like this could be on GitHub. Like, what if every library that you used had like some interactive documentation or interactive representation that allowed you to like play around and see what data was flowing through the program, and the author could maybe like add annotations being like, oh, and this is what I was thinking here, and this kind of thing.
The dream.
Well, I think the final dream that this is pointing at is like, I want to start with a representation that is like me trying the best I can to explain how this thing works in the best possible way that I know how. And so it's very handcrafted. It's not automatically generated or something like that. But starting with at least one good example of a well-explained system, is it possible to get any lessons from that to be able to explain other systems, with the hope that these things may just be automatically generated in the future, or may become the way that the programs are authored in the first place, working with a really good representation of that system that's really human understandable, instead of, symbols and code.
I stand corrected. That you're correct. That what you just said, that is definitely a dream.
yeah, that's my dream, or at least something I'm trying to point at with this library.
Totally. No, I have the same dream. We're co-dreaming here. Awesome. So in terms of this and future work from Flowsheets and the Flowsheets SaaS startup and et cetera, how should people follow you? What sort of ways are you interested in interacting with listeners of the podcast, et cetera?
I'm on Twitter. My Twitter is at Glench, Glench. I'll post about random programming things that I do, including this representation I just showed. I also have a newsletter about the future of programming on TinyLetter, and that's tinyletter.com/flowsheets. And I'll post things about that's the main kind of venue. I'll talk about the different prototypes and things I'm coming out with. And my website is glench.com, glench.com. And that's the kind of my repository of everything I've ever made. Yeah.
Cool.
And I don't know when my SaaS startup, my programming language startup is maybe another way of saying it. I don't know when that will be coming out with a thing, but hopefully before the end of the year.
Are you? Is there anything you're looking for, like investors, collaborators, employees? I don't know, early customers. Anything you're looking for? Or is it too early?
That's a great question. Thank you for asking. No, I'm not really looking for anything at the moment. I'm in the middle of doing a lot of customer interviews and really trying to understand what kind of data manipulation tasks people are doing. Especially in an automated way or wanting to be an automated way. So things like, I want this data manipulation task to run every 15 minutes and email me if some certain conditions happen. So if anyone has any tasks like that they'd be interested in telling me about, I'd be happy to hear them.
Cool. And people should get in touch with you via Twitter, email?
Yeah, Twitter works, and email. My email is on my site.
Cool. Great. Well, Glenn, it was a pleasure. Thanks so much for giving me so much of your time. This was awesome.
Thanks for having me, Steve.